And we're playing. All right, so what kind of questions did you see on either of those pages that I could help you out with? Yes, ma'am. On which page? G17. Was it a word problem?
No.
Okay. Oh, okay. Oh, perfect. Number 17. Show up. Good. Yay. So I have y equals 3 sine x minus pi over 4 plus 1. Okay, so the nice thing when you look at it, there's nothing in front of the x. That means that our period is going to go from 0 to 2 pi. And that's pretty much, I will not have a combination of things. I won't have that happen. I'll have one or the other happen. And these are going to be the same rules that I would apply to cosine. It's just, you know, that cosine either starts at a max or a min, depending if you have a negative out front. And sine always starts at the midline. All right, so let's do this. I'm going to draw these as dotted. Reason I'm drawing them as dotted is I don't want to say that they are firm lines that always have to be there. So let's figure out, that's going to tell me my midline is going to be 1. So that means that that horizontal line is no longer the x-axis. Agree? This 3 means it's going to go 3 above that and 3 below that. So if this is 1, then this goes up to 4. 3 below that goes to -2. Agree? And I have enough information to start graphing it at this point. So normally this would have been pi halves. Obviously here is 0. This is pi. This is 3 pi over 2. And this is 2 pi. Agree? So let's go ahead and make our graph based on that. So it's sine. So sine means it's going to start at midline. There's no negative out front. So it's going to go here, up here, down here, become a minimum, go back to the midline. So our sine curve looks something like that. Okay? Now let's take into account what this is going to do. This is going to go right pi fourths. Okay? It goes right because it's the same shifting pattern that takes place when anything else was grouped with graphing. So this basically means if I go to the right, that means I'm going to add pi fourths to all of this. So 0 plus pi fourths, that means this is going to be pi fourths. I'm going to add pi fourths to this. I'm going to add pi fourths to this. I'm going to add pi fourths to this. And I'm going to add pi fourths to this. So now we just have to think, okay, can we decipher? So 0 plus pi fourths, that means I have pi fourths happening here. So I could put it right here, maybe in black. Pi over 2 plus pi over 4. So I'm going to make this 4. Nope, we'll make this 2 pi over 4. So if I add 2 plus 1 pi, I'm going to get this to be 3 pi over 4. And then if I add pi fourths to this, I'm going to make this 4 fourths pi. So 4 plus 1, that's going to give me 5 pi over 4. If I add this, I'm going to get a common denominator, so I'm going to make that 6 over 4. So 6 plus 1 is 7, so I get 7 pi over 4. And then if I add this, I'm going to make this 8 over 4. So 8 plus 1, that gives me 9 pi over 4. Now everything is labeled appropriately. We realize the pink y-axis and the pink x-axis are truly not there. Where do my true x and y axis actually exist? This is where my axes actually kind of exist, like here and like here. That's kind of where, but you don't have to know that because you've changed the labels, which shows me you have the understanding that shifting's taken place. So you use the XY axis kind of as a guide, but it doesn't have to become a firm truth. Does that make sense?
Yeah.
Cool. You're welcome. What else would you like to see on either of those pages, my friends? Anything else? Going once. I'll give you time to look. Hopefully these are good in the hood. You feel all right? Yeah.
Okay, one thing is I'm just trying to figure out for like okay, so is the same equation for the sine the sine equations? It's the same for cosine?
Yeah, it's just so sine will always start at the midline. Okay, and if it's positive sine, you know, no matter what the value is, as long as it's positive, it would go up from the mid. If it was negative sine, it would go down from the mid. And then cosine, it starts as a max or a min. Okay, so which means, so sine will either do this or it would do this. Oops, that was really bad. I tried hard and I failed. So that's basically what the sign is going to do. This would be the positive sign. This would be the negative sign. Cosine, you're either going to start like at a max. So this would be positive cosine, or it would start at a min. And this would be a negative cosine.
And then the equation, I'm just trying to figure out, because like I wrote down some of it, but like for this one, what is C for the A sine?
Oh, is that on the notes?
C plus B. Yeah, I just didn't write down.
Can I see those notes real quick? That was, I'll just generate this over again. So we had this graph. It said this was 0, pi halves, pi, 3 pi over 2, 2 pi. So a normal thing, it goes up to 2 and it goes down to negative 2. And it's just a traditional sine curve. And so you have y equals a sine, and then the bx plus c plus d. Okay, there you go. So first thing I'm going to kind of show is if you have something like this, it's good that you understand that that's the same thing as bx plus c over b, where you factored out the b. Okay, this one, fortunately, the only thing that this is just y equals 2 sine of x. It didn't shift up or down at all. It didn't shift right or left, and it didn't happen more times between 0 and 2 pi, because 0 to 2 pi is one time around the unit circle. So the only thing that we modify on this one is just the a value. This middle part here, there's a lot of different terminology that they'll use for it. I like showing that b value comes out, because then you go 2 pi over whatever that b value is, and that tells you how long your period is going to take place. Other teachers will show it this way. They call it drop it in the middle. And if you have a tutor at Sacamano, they might call it that. And some of the pre-calc teachers might teach. My way versus their way, there's not one way that's better than the other. It's just a term that they use. So when they say socket in the middle, let's say we had an equation that looked like this. So let's say we had that, okay? And sometimes they would call this theta. Theta means the same thing as x. So what you're going to do is, you know that your normal routine goes between 0 and 2 pi, right? So you're going to stick that in the middle. So you're going to do that. And then if you do the math to it, and then divide by 3, that is where your shift took place. But this is the same math that I'm doing, that when I say we're going to add or subtract it from our 0, pi halves, pi, 3 pi over 2, 2 pi. This is the same math. So this is you might see this in your pre-calc class if you take pre-calc. If you take the college trig, you might see it my way or this way, or might maybe a blend of the two. And it's kind of like, when you went back to the days of factoring, there's the grouping method of factoring, x squared plus 5x plus 6. There's the guess and check, the 90-10 rule, the box, the diamond, the square. I mean, there's so many different ways. So what is the right way? The way that your mind makes it work. But basically what this does is this tells you if you started at negative 2/3, and this is kind of a nasty one because, where's negative 2/3 as far as radians goes when we're counting by pies and pi halves and 3 pies over 2? This would be a hard one to kind of look at on the graph. But what this would do is this would allow us to, this kind of shows the shift algebraically. I've been showing you the shift graph using graphing. And I can't tell you which one's more correct. And I don't think if you were to take it, say, an AP Calc class and you had this kind of thing and they wanted a graph, I think that AP grader knows about 25 different ways that could be asked. I mean, the AP rubric for that type of question, if this was available, and this is probably not an AP question, but they'd be like, did the student do this? No, they did this way. Did they do this way? And then they all grade it, and then they turn their paper over to a second grader, and the second grader grades it. And then if there's a discrepancy in the grade, then they bring in over a mediator to talk about, this or that. So it's just, so does that make sense? Or did I just screw up everything now? Okay. Anything else, my friends? Ready to take a look at tangent? And again, I will not make you do tangent on the quiz. It's just you guys get the bonus of it because, well, you guys got gypped out of a snow day is really what it came down to. Right? All right, so we're going to talk about the understanding of doing tangent. So I just want us to realize we know that that happens at 0 and 2 pi. This happens at 0, 1, which is at pi over 2. This happens at negative 1 comma 0, which is pi. This is the point 0, negative 1, and this happens at 3 pi over 2. Okay, and that's just going around the unit circle as a counterclockwise motion. Okay, so the main numbers you're really looking at with tangent, so we have to realize that tangent is equal to y over x. Okay, does anyone see a discrepancy that's going to take place with tangent if I go y over x? Something you learned about a long time ago. You tried to figure out on your calculator why something didn't work. You got error. It's when you had that 4-function calculator you found in the kitchen drawer, and you went like some number and you went divided by 0 and it said error. Remember that? Did any of you do anything dumb like that? I did. So an error takes place when you divide by 0. So there are certain things that are going to happen on our unit circle that you have an undefined term. An undefined term creates one of two things in math. It creates a hole in your graph, and we'll talk about holes after spring break, or it makes an asymptote. A hole has a higher order no factor than an asymptote. So if you have a hole, you don't have an asymptote where a hole is. You don't have a hole where an asymptote is. But if your equation came out to say, hey, there's a hole, you go with the hole, you don't go with the asymptote. And now that I messed you all up on that, it'll make sense later. You'll see that. All right, so we have 0, pi over 2, pi, 3 pi over 2. And you probably are starting to notice that I just been doing a lot of stuff in radians. And the nice thing about radians is you get to see the whole thing, and you're not dealing with 0 to 360. You're dealing with 0 to 2 pi. So 2 pi is 6.28. So that's the kind of the nice thing about it. So think about this as far as the unit circle. If I were to take 0 degrees, if I go y over x, I get 0 divided by 1, which is equal to 0. Okay, so I'm just going to go ahead and plot that right there. Okay, and it's a nice, solid, firm point. I like it. But then I'm going to go to the next point. I'm going to go to this point right here, which is 0, 1. So again, if it's y over x, I get 1 divided by 0, which is undefined. So at pi halves, well, let's just call this pi halves right here. This is a vertical asymptote. So you just kind of draw yourself in a dotted line. Hopefully you make it vertically straight and not with some tremors like stirrups got. And then you get to pi, you're over here, and that's negative 1 comma 0. So that becomes 0 over negative 1, which is equal to 0. So if this is pi right here, you got a 0 right there. Okay? And then I'm going to throw in there 3 pi over 2 right here. 3 pi over 2 is down here, which is 0, negative 1, which becomes 1 divided by 0. This was also 1, or that was 1. That's negative 1 divided by 0, which is undefined. So here we have another asymptote. If I get to 2 pi is the same thing as this, so that's 0. But if I went the opposite way, this is going to mirror itself over here. So over here, that's negative pi halves. This is negative pi. This is negative 3 pi over 2. And negative 2 pi. So I also have the asymptotes here. I have a 0 here. I have a 0 here. All right, so now you have to decipher what the graph looks like and why. Asymptotes, my graph can't cross, especially vertical ones. There are a few routines in horizontal that it can cross, but vertical ones are a big non-crossing situation. So if you kind of think about this, I never can remember the direction that it's going to go. But I know that 45 degrees or pi fourths is the point root 2 over 2, comma, root 2 over 2. So if I did y over x, I'd get root 2 over 2 over root 2 over 2, which that means at pi fourths, we're at 1. So think about where pi fourths is. Pi fourths is right here. Oh, and that happens at 1. Okay, here's my tangent graph. And I just use that pi fourths to give me a reminder of what our graph would look like. That's the tangent graph. And the reason it looks like that is because you have undefined terms at certain locations on the unit circle as you go around. Okay? It's kind of pretty. The reason I use that pi fourths is just because my small mind can't remember the exact location of what the graph looks like every time. So I go to the pi fourths, I realize pi fourths, tangent of pi fourths is equal to 1. Oh, pi fourths is between 0 and pi halves. Kind of just do that as an indicator. You all are all smarter than me. You probably don't even have to do that step, which I'm so proud of you. We good? So that's just regular tangent x. All of the right-left shifts just move the asymptotes and where it crosses the x-axis. Okay? If you have a number out front, that just makes your thing start becoming taller. So rather than at pi fourths being 1, if you had a 2 out front, it'd be pi halves, comma 2. If there was a 20 out front, it'd be pi fourths, comma 20. So it just starts straightening in your graph out even more, but the asymptotes and everything like that still stay in place. So I guess it just changes the slope. So if we looked at this situation here, we have to decipher what our midline is. Well, this right here looks like my midline, so I have a negative 1. And then I am going to, let's see, it goes from 0 to 2 pi. 0 to 2 pi. Does this point look like it'd be about the same point right here horizontally, which then would pick up like on that? So cool. It looks like my period is still 2 pi. And let's figure out our equation. So the equation is going to be y equals tangent of x equal or minus 1. Because this made a shift of 1. Okay, so tangent x minus 1. That's all it is. Okay, again, I had to think about would this start repeating itself? Oh, when will it start repeating itself? I can see my entire graph here. So this is going to continue down. So if this is pi, or negative pi, and this is positive pi, this distance here, that goes to negative pi. This distance here goes to pi. If it's a distance, that has to be positive. So pi plus pi is 2 pi. So that tells us that we are on one rotation around our unit circle without any modifications. Can I move on? All right, so midline, again, I'm looking here. So I'm going to say positive 2. How far is this distance here? What do you think? So this distance here is pi halves. This distance here is pi halves. Yeah, so that becomes 2 pi over 2. So that's pi over 2. So my period is now pi. Okay? So my period takes place over pi. That means in front of the x, or they could call it theta as well. It's going to mean the same thing. We need to say we're only seeing, our graph is going to start happening twice as fast. Okay, so I'm going to get y equals regular tangent. It's not any taller. Tangent of two pi plus 2, or 2x. That should be a 2x, I'm sorry. Okay, this x here, this 2 in front of the means it's happening twice as fast. Okay, normally it goes from 0 to, it has a distance of 2 pi. This one has a distance of pi, so it's happening more often. Can I move on? And the plus 2 is because it shifts up. All right, this one, take a look at one iteration. This distance here is still pi. Okay, so that's going to happen a little differently. That's 0, so I have midline of 0. I have a period of pi. So this is just going to be y equals tangent of 2x. Done. Yeah. Go back to it. Oops, wrong way. Go ahead. Oh. Oh, you're so smart. What should I have there? Yeah, negative. Because I didn't even realize it. The graph went the opposite way. There's a negative out in front. Oh, man, if I wasn't here, I'd be making error. Or if you guys weren't here, I'd be making errors. People would be pointing and laughing. Yeah, that negative because the graph went to this rather than this. Thank you. I wasn't expecting that to come up so quickly, but it serves me right for not looking for it on my notes. Good job. Can I move on? So we had covered that one. That one's good. Graph looks fine. Then we have to look at this one. Let's see. Midline appears to be 0. They give us a couple extra points. So let's see. So there's some asymptote somewhere in here, somewhere in here. So let's see, how can we figure out the asymptote? Well, this is kind of a cruel and unusual problem they gave us. So what is this point here going to be? So let's see. I got 1, 2, 3, 4. So I'd say pi over 8, 2 pi over 8, because that's 1/4, 3 pi over 8, 4 pi over 8, which reduces to the pi halves, 5 pi over 8, 6 pi over 8, negative 2 pi over 8. Ooh, so I'm going to go from here to here to see what the distance is. So I have 2 pi over 8. Now keep it positive. And this is going to be 5 pi, 6 pi, 6 pi over 8. So that's going to give me 8 pi over 8, which reduces to pi. Oh, okay, my period is just going to be pi. So it's going to happen twice as often, so I'll have a 2 after my x. The direction goes correctly, but it did shift left at negative 2 pi over 8, so negative pi fourths. Okay, so I'm going to go y equals tangent, happens twice as often. Oh, happens twice as often. Twice as often, and it shifted left, so that's going to be plus pi over 4. So if I didn't want to have double parentheses, if I distributed this over, that's going to give me 2x plus pi over 2. Or if you wanted to show the shift, you could do this. Tangent 2x plus pi over 4. So I think both those answers are correct. All right. I'm going to move off that one. I think we are okay to be done because I'm not testing you on this. I just wanted to expose it to you originally. I'll call it good. Sound all right? That way it only gives the other class choose to.